In section 6.3, we started off with our problems being rotating around the x-axis, and then we switch it up to be, some kind of other horizontal lines. For example, y is equal to something negative, y is equal to something positive. We generalize the method to be about rotating about different horizontal lines. In section 6.4, the Shell's method, we start off by talking about rotating around the y-axis, a vertical line. Well, let's mix up a little bit. Let's see what goes on if we switch up where we're rotating around. So find the volume of the solid obtained by rotating the region under the graph of y is equal to 9 minus x squared. X is running between 0 and 3, about the line x is equal to minus 2. Okay, so let's draw a picture here. So y is equal to 9 minus x squared. So 0 to 3. So this is the region that we are going to revolve. And so our initial thought might be rotate around the y-axis, but actually the axis that we were told to rotate around is x is equal to minus 2. Okay, so this is the setup that we're going for. And so let's take a look once again at our big formula here. So this is for about the y-axis, so we're going to have to make changes here. So the volume is 2 pi times the integral from a to b, the radius times the height of the shell, dx. Now, what's going on here? The heights of the shells here, if we, just because we're rotating around x equal to minus 2 instead of the y-axis, that's not changing the height of the shells. So in our formula, this is not going to change at all. We're still going to put in an f of x. We're still going to put in this case, 9 minus x squared. However, the radius is how far away we are from the axis we're rotating about. Well, we were initially here. Now we're all the way over at x is equal to minus 2. So the radius when x is equal to 0 is now 2. The radius when x is equal to 3 is 3 plus 2 is 5. And so a little bit of thought should convince us that we're just replacing the radius x here with x plus 2, because that's going to be how far away from the axis that we're revolving around is going to be. So putting all of this together, our volume is 2 pi times the integral from a to b, and that's still going to be 0 to 3, the region that we're rotating around. And then the big change here is that x is replaced with x plus 2. And then what else is going on here? We are replacing 9 minus x squared. So the height of the shells, that's just 9 minus x squared. So this is what the integral we have to evaluate is. Okay, let's go ahead and do this. X plus 2 times 9 minus x squared, so I guess we just have to expand this out. So we should end up with 18 plus 9x and minus 2x squared minus x cubed. And so taking the antiderivative here gives us 18x plus 9 halves x squared minus 2/3 x cubed minus x to the 4th over 4. Plug in 0 and 3. Plugging in 0, of course, is going to make all of that 0. So 2 pi times 18 times 3 plus 9 halves times 9 minus 2/3 times 27 minus 81 over 4. You can simplify that if you want to, but that is our final answer.